Now let's actually create our AI agent, which will then utilize the RAG architecture as well. So this time we're going to create another trigger. We are going to create a chat trigger. We can make this publicly available if we want to, that's absolutely fine. And we can play around with some of these configurations here, but to be honest, none of this is really that important. So let's move this down here and let's just start things off with a very simple chat message just to kick things off. Good. So obviously nothing's happened at the moment because we've not connected it to any nodes. Next thing we're going to connect it to is our AI agent. So the source for this AI agent is of course going to be the chat trigger node, so that's absolutely fine. There's nothing we really need to do here apart from adding our chat model. In this example we're going to be utilizing an Anthropic model, but of course you can choose whichever model you please. We're going to give it some memory as well, and I'm going to give it a context window length of 5. So the reason why memory is important is because you want your chatbot to have memory and you want it to understand what you said to it previously. So if you've used ChatGPT before, you can input a whole bunch of questions and you can have a conversation, it's backwards and forwards, but then quite often it will reference things that you said earlier or examples that you gave previously, as well as its responses. So in this example, we're giving it quite a short memory window length of just 5, but you can extend this to longer if you wanted to. Of course, the longer the memory, the larger the window size, the more tokens you're going to use in your input to an LLM, so it will become more costly. This is another thing that you have to consider when building out conversational agents and AI agents in general. And it's something that can get quite complicated depending on the use case. But for now, we're just going to give it a context window length of 5. Okay, so we've got our AI agent, we've got the chat model, we've got the memory. We haven't actually configured the AI agent yet, so it's not really going to be that useful at the moment. But what we can do is we can start to add tools. And one of the tools that we want to use is the vector database tool. So we're going to utilize the same vector store node that NAN has inbuilt. We are going to retrieve documents as a tool for an AI agent. Let's just call this our knowledge base. Now what's important here is to make sure that the memory key matches the memory key from the loading of the data that we did previously. We're just utilizing the standard memory key name here, so this is the same as the previous time when we loaded the data, but just make sure that this memory key is the same. And we're going to limit the number of results that are returned when we query data from the vector database to just 5. So what this means is that when an input query is given, so for example, what's the best use case for NAN, it will go to the vector database, it will find the top 5 best matching vectors to that input query, and it will return the text values that are associated with those vectors. And we can give it a description as well. So this is a knowledge base to be utilized by our AI agent. Okay, so fairly simple, and we want to use an embedding once again. We're going to utilize the same embedding model as we have before, which is quite important, because the reason why this is important is because if you embed your input query with a different embedding model to the embedding model that the knowledge base has been embedded in, then you may get quite wild and variable results, because different embedding models will generate different vectors for specific text queries. So that all looks fine. I think that's pretty much everything that we need. The only other thing that we need to do is we need to come into the AI agent and we need to add a system message. This is essentially just going to give some guidance to the AI agent in terms of what its role is, what it needs to do, the steps that it needs to perform in order to generate a response. And for this, I have pre-prepared a template that we can use. So I'm going to put this in here. Now I have created another video on how to optimize your LLM prompts, and this uses some of the principles that I went through in that video.